Okay, before I get real far into an explanation of how this works, I just want to note a couple of minor changes that I've made to the code. Right here, I've changed this from chunk size to chunk size times 2, and this one also to chunk size times 2. So when we read from the mic, I thought that this number was the number of samples, but it's really the number of bytes in the array of bytes. And since each sample has 2 bytes, and chunk size is the number of samples, we have to multiply by 2 to get the total number of bytes that we read. And the same here. Now, everything worked in the last program just fine because we were reading the same number of bytes from the mic as we were writing to the speaker, and everything worked fine. But when we add the visualization, we're passing an array that was only half filled, essentially. And so all of our visualization came out just on half of the screen. The next thing I'd like to note is that I've shortened this up a little bit. There was a little bit of code, an ampersand 0x capital F here, and here. And in putting together the explanation of how this all worked, I realized that those were completely unnecessary. They really had no effect at all. I will explain what those are and why they, why they might matter. But for this particular application, they are unnecessary. So, so let's get into that explanation of this really crazy convert method. All right, so I've just copy-pasted and enlarged the original convert method a little bit, and I've drawn the heap and the stack. Okay, so when you call the convert method, a little memory is set aside on the stack for that convert method and its variables. And so some of the variables that it has, it receives a buffer2 variable, and so that buffer2 variable is here, which will point to a byte array which is in memory. And so that byte array is on the heap, and that buffer2 variable is a pointer to it. And then it creates, as soon as it starts running, it creates a new array of shorts on the heap. That's what this is. And so that's what that is, and it assigns that to a variable temp. And so it's got a variable temp that points to that array of shorts. Now, what is an array? I'm not sure exactly that I have explained what an array is in great detail. So the idea is that an array is just a group of some other variable. Okay? So as soon as I see new short and then this calculation is just a number. Okay? So buffer2.length tells me how many items are in that array, in the buffer2 array. And then if I divide that by 2, there are going to be half as many items in this one. So I've labeled this as if it had 15 items and this one as if it had 6. But if this one indeed, if it's going to have an even number. So I'm just going to erase a little bit. I'm going to erase and say, all right, let's say it has 12 items. And if it had 12 items, then the other one is going to have 6. Because its length is 12 items. I got to be careful here. It is important to note that the first index is 0. So what is an index? I haven't even explained that. Well, we can count the number of items. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 items in this array. It's an array of bytes. A byte is 8 bits. Each bit is either a 1 or a 0. So the idea is that this buffer is going to hold 12 bytes. Each byte being 12 bits. So this little spot in that array might hold a 10110001. It's just a chunk of information, and at the lowest level, the computer stores all that information as ones and zeros. Now, so a byte is 8 bits. A short is a number, just very similar to an int, okay, except that an int is made up of 4 bytes or 32 bits. That's how much memory it takes. Okay, so we measure an amount of memory in bytes or bits, where a byte is 8 bits and a bit is just a single 1 or a 0. A short is only half as long as an int, so it only takes up half as much memory. It takes up 2 bytes. So it's going to take up 2 bytes for each short. So this is going to have an array, and that's why we set it. We're going to copy the information from this array into this one and kind of reformat it a little bit along the way. And so we allocate a new chunk of memory that is just big enough to hold all the stuff in here. It's only got half as many spots, but each spot is twice as big. Each spot is a short instead of a byte, and there are half as many spots. So that's what this does. This creates the array in memory, and then when it's created, we assign its value to the variable temp. The type of that variable is array of shorts, so when we create a new short array, we can assign that array to this variable. And so temp gets a pointer or a reference to that. And this for loop, what does this do? It starts out a variable I as 0. And then if I is less than the length of the array, okay, the array length is the number of items in the array. So as long as I is less than the length, it's going to perform this instruction down here. And the idea is that this instruction is going to take 2 bytes, format them, and store them into one location down here. Okay, and I'll go into more detail of exactly what all of this is to do the formatting in a moment. Then we add 1 to I, and as long as it's still less than the length, we copy the next 2 bytes of data. We format them and put them in the next spot. And it just keeps going around this loop until grabbing 2 bytes at a time until it has grabbed all the 2 bytes. And you say, okay, so how is it grabbing 2 bytes at a time? See, buffer with the square brackets 2 times I plus 1 and buffer 2 times I. Okay, so if I is equal to 3, then I is, when temp sub I, is going to point to this spot right here. And buffer sub 2 times 2i plus 1, what's 2i plus 1? That's 7. Okay, so 2i plus 1, buffer 2 sub 2i plus 1, when I is 3, is going to point to this spot right here. And buffer sub 2 times I is going to point to this. So I'm getting 2 adjacent, right? They're adjacent because the only difference between my indices here, inside of the square brackets, I've got something that evaluates to an integer. We call that an index. And the only difference between this and this is the plus 1. So those 2 bytes are going to be adjacent. This one being the one with the smaller index, and this one being the one with the bigger index. And I really probably should number my array from the right to the left. But usually the bigger index is on the left, but oh well. It was more convenient for me to draw it this way. Let's see. So let's talk a little bit about what this this is called a left shift, the double less than symbol. And what this ampersand 0xFF is about. So let's talk about different representations of numbers. There are 3 commonly used. One is base 10. That's the one you grew up with. There are 10 different symbols, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I've just listed the first 16 base 10 numbers, okay, 0 through 15. Hex is just a different representation of the same numbers with the symbols 0 through 9, A, B, C, D, E, and F. So the symbol A is going to just represent the very next number, okay? So A represents 10 in base 10, and B represents 11, C is 12, D is 13, E is 14, and F is 15. It is common in computers, in programming, every once in a while to represent a number in what's called hexadecimal format. And you tell the computer that you're representing the number in hexadecimal format by typing a 0x and then the digits of the number. So 0xFF. Well, in binary, okay, so this is the first digit, second, third, fourth. In binary, an F, so if we take the hexadecimal number F, in base 10, that's a 15, and in base 2, or binary, it's a 1111. So 0xFF is 8 bits, okay, so you've got 4 bits for each, 4 binary bits for each hexadecimal digit. 0xFF is just 8 ones in binary. So what is this ampersand thing about? Okay, and we had a student who was a little bit confused on that. He was using the ampersand, well actually he used the caret symbol, which is, it's called a bitwise operator. And I think I've seen somebody use a single ampersand also when they were trying to do something, or maybe you've tried, where you were trying to use an and or an or. The caret, somebody was trying to use that for exponentiation, because that's what it is in your calculator. But it's something different in the computer. The ampersand is an and, but it's a bitwise and. So it's going to take a number on the left and a number on the right, and it's going to and each digit individually. So if I've got the number 1110 and the number 0101, if I and that together, each digit in the result is going to be a 1 if there's a 1 in both of these. That's what and means, if it's in this and this one. So this first digit, 1 and a 0. They're not both 1, so I get a 0. And then the next digit is a 1 and a 1. So this digit becomes a 1, because they're both 1s. A 1 and a 0, therefore this is 0. And a 0 and a 1, therefore this is 0. If I take the same two numbers and OR them together with a single bar, it does bitwise ORing. So if either this or this has a 1 in it, the result will be a 1. So a 1 or a 0 is a 1. A 1 or a 1 is a 1. A 1 or a 0 is a 1. And a 0 or a 1 is a 1. Okay, so that's what the bitwise operators are. It's a little bit different than the Boolean operators, where you've got, instead of a single ampersand, you've got a double ampersand. A true and a false is false. A true or a false is true. And so the idea of this ampersand is that it would take these 8 bits and them together with these 8 bits. And the reason why I said it had absolutely no effect is because if you and something with something else that's all 1s, all you're going to end up with is the thing on the left. And so I've deleted this bit of code. It's really kind of useless. What's this about? The 2 less than symbols. This is called a left shift. So if I have a number 0010 and I left shift it by 2, I get the number 1 0, 0, 0. It has shifted all the bits to the left by 2. So why do I want to do that? Because what we're trying to accomplish here is if we left shift by 8, we're shifting whatever this is by 8, and it's going to pad zeros to the end. So it's turning this 8-bit number into a 16-bit number. Actually, whenever you left shift or right shift, it causes a conversion from type byte to type int. So it's now stored, instead of 8 bits, it would be stored in 32 bits. So you're going to have a bunch of, you're going to have 16 zeros on the left, and then some ones and zeros, depending on 8 ones and zeros, depending on whatever was stored in the buffer, and then 8 zeros. And then when you add this other number with 8 bits in it, you end up with a number that has 16 zeros. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Because there's no way for those to be, when it converts it to an int, for them to be anything other than that. And then you've got 8 bits determined by buffer. I'm just going to put some underscores. 1, 2, 3, 4, 5, 6, 7, 8. And then 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. Where this group of 8 bits is determined by this right here. And this right here determines this group of bits. Okay, so if I add two numbers, since all of these would have been 0, and this one wouldn't have had anything, it would, if I add an int to a byte, it's going to convert the byte to an int, so they both end up being ints. It does integer arithmetic. And because those were all zeros, it just added these into those spots. And because this one had zeros in that spot, it put them there. So then we do a conversion to a short, which essentially, this conversion to a short just chops off the first 16 bits, so that you can store it into this memory location, temp sub I, which is only able to hold these 16 bits. So this crazy bit of code, all it's doing, in a nutshell, is it's taking 2 bytes, pasting them adjacent to each other, and storing them in to a short, a location in an array that can hold a short, because we would like to treat it as a number, like an integer. Okay. How long is this video? Oh, it's getting to be a little bit long. I'm just going to finish this video up real quick with what I'd like you to do for your assignment. So there's essentially two things. On the web page, I have made a link to a worksheet. I would like you to download that worksheet. This is what it looks like. It's got decimal numbers in the first column, hexadecimal numbers in the second column, and binary numbers in the third column. And I would like you to fill in the blanks. So if I've got the decimal number 1, I would like you to write that decimal number 1 in hex, and in binary, and then where I've got the decimal number 255, I would like you to write that in hex and in binary. Where I've got the hexadecimal number 10, I would like you to write that in base 10 and in base 2 in binary. Where we've got this binary number, I would like you to write that in hex and in base 10. And essentially, you know, so on. Just fill in the table. I would like you to put the file, so when you download it, put it in your project folder, fill in the empty spaces of the table, and then zip and upload your project. I would like you to implement all the code that I've shown in my videos, and then, yes, add something to it, something original and creative. What you might do is color the bars by their height, or you might make fewer bars where you average several bars together to get different numbers. Let's see, what else might you do? You might, instead of having bars, try to draw circles that change size with the height of the bars. Or I mean the size of the values, or change your visualization in some different way. I'm sure that there are other ways to do it that I haven't expressed. Please try to get creative and do the worksheet. I did have a student who specifically requested that rather than just me providing you with code and saying, okay, here, copy my code and make it run, and try to be creative and add something to it. He wanted something much more specific where I gave him a specific assignment with right and wrong answers that was not just copying code. And so that's essentially what the worksheet is. And I will try to do more of that if students, if you have specific wishes, if there are certain things that I need to do to provide you with the best learning experience, please let me know. If I make a change to the way that I'm presenting the course, it is very likely a result of some student who's asked me to do something a little bit different. If you like it, let me know. If you don't like one of my changes, let me know, because you might not all agree as to what's best, and I will try to satisfy as many of you as possible. Thanks, have fun, and I will change the due date of this assignment because I did post the last details a little later than I'd originally intended. Thanks, and if you have any questions, please send me a message. Try to have fun.